All right, so lesson 14 was made up of terminating decimals and repeating decimals. All right, remember, anytime your remainder is 0, your decimal stops, and that's a terminating decimal. If you end up having a remainder that's different than 0 over and over and over, then that's when we get into the repeating decimals. So here are all of our terminating decimals. Now, one thing I want to point out that we were talking about is, do you guys agree that that is a proper fraction? It is not improper, right? What are some qualities a proper fraction needs? The top number needs to be what? Smaller than the bottom number. Good job. Now, think about this. If we have a smaller number on top and a larger number on the bottom, will our decimal always be 0 point something? Yes. Okay. So the thing I need you to realize is the top number goes in the box. The top number goes in the box. Always. It doesn't matter if it's bigger or smaller. We just know that with a proper fraction, we're going to get a 0 point decimal. This one here was a long division. Look at all that, okay? All right, so now when we look at our repeating decimals, that is where we ended up having a pattern. And then do you guys remember we ended up putting bars above our pattern? Yes. If our pattern was long, our bar was long. All right? If our pattern is short, we still need to put it over everything that repeats. And that's where a majority of our lesson is going to go today, is the repeating patterns. All right? We just have a few more things to talk about. So, how do we determine whether the decimal representation of a quotient of two integers with the divisor not equal to 0 will terminate or repeat? Do you guys remember this part? So it's kind of wordy. So we need to tap back almost probably a week and a half here. Do you guys remember the lesson that we did where we didn't do any dividing? And we just did 2s and 5s? Do you remember that? Okay. So this is what we need to realize. If your denominator is made up of a tree that's either 2s, 5s, or 2s and 5s, it's going to terminate. Anytime you have anything else in your tree, a 3, a 7, anything, it's going to repeat. So let's look at a couple of examples here. Let's do 1 over 16, let's do 3 over 8, and let's do 5 over 9. Okay? So I want everyone to write this down right underneath that one there, just like I did, right under example 5. And what I would like you guys to do here is I want you to tree down 16, tree down 8, and I want you to tree down 9. So again, remember, we're looking at what numbers multiply to equal those. So 16, you could start with 4 times 4. You could start with 2 times 8, but don't start with 1 and 16 because we're looking for prime numbers. 1 is not prime. Prime numbers only have 1 in itself as a factor. I'm going to tack on one more here, so as you guys work through these, I would like you to do the 3/10 also. Let's look at these. Do you guys agree that 16's tree is made up of 2's? Okay. Do you guys agree that 3/8's tree, or for the 8, ends up in 2's? Okay. Do you guys agree that 3/10 end up in 2's and 5's? All of those will terminate. Why? Because they're either made up of 2's, 5's, or 2's and 5's. What can we say about 5/9 here? Okay, there's no 5's or 2's. Now, we could have some 5's or 2's, but those 3's make it a repeating decimal automatically. Okay? So when we look at letter A here, it says, Eric and 4 of his friends. So how many people is that?
4.
Nope, Eric and his friends, that's 5 people, correct? All right, they're going across basically a toll bridge, and the total cost is $8. We want to figure out how much each person is going to pay. So my question for you guys, will each person pay more than $1 or less than $1? 5 people, $8. More than $1, right? So if we think about this, which one of these is going to make sense then? Everyone agree with that? Yes. You guys just told me they're going to each pay more than $1. Wouldn't that be less than $1? Yes. Proper fraction, right? Okay, so now my question for you guys, which one of these is going to happen then? The first or the last? The first one. Does 8 go into 5 here? No, it doesn't. Will that create more than $1? Less than $1. So it cannot be this one right here. Okay, now before we divide, what is our denominator made up of? 2 and a 5. What does that mean about our decimal? Is it going to terminate or repeat? Is it made up of 2's and 5's? It's going to terminate. Okay, so I want everyone to go ahead and take 8 divided by 5 and get your terminating decimal. It might be a longer terminating decimal, but it is going to terminate. What do you guys notice in my division? Do I have any zeros to bring down? Can I? Okay, if we're going to put on a 0, we got to put on a decimal. Exactly. So now I can bring a 0 down here. I end up with 60. Okay.
Are you starting at the beginning? I started at the 0 at the beginning.
Okay, did you add the decimal at the beginning? Okay, that's fine then. As long as it's paired together and you end up with both of them, that is fine. $1.06. Does that sound right?
No, $1.60.
$1.60 each. Okay. All right, so let's look at this next one now. Oh, it's family emergencies, sickness, things like that. 2 of his friends don't get to go now. How many people are crossing the toll bridge now?
3.
3, yep. So now we have 8 divided by 3. What do you notice about my denominator? It's improper, but my denominator specifically, is it made up of 2's and 5's? No, it's made up of a 3. What does that mean about my decimal? It's going to repeat. Okay, so I want you guys to go ahead and divide and figure out what the repeating pattern is. Is it still more than $1 though? Yes. They're going to pay more than $1. They're going to pay even more than what we did with 5 people. Some of you were saying, I just put the decimal and zeros on at the very beginning. That's fine, as long as a decimal and a 0 are paired together. Okay, what pattern are you getting down here? What are you getting for your subtraction always?
20.
Not 20, but 2. You're getting 2 each time, right? Because we're going to put this here, we're going to get 2 and then bring down our 0. All right, in decimal world, that's what we would say. But now in money world, careful. We talked about calculator screens. $2.67. 5 or bigger ends up rounding up. Very good. Okay. Okay, so before we get going on our lesson today, let's go ahead and check some of these. So, did we get 0.3 repeating all the way across here? Good. Do you guys agree that those are equivalent fractions? What do they all simplify to be? 0.3 repeating or 1/3 as a fraction. Okay. Do we agree here that all of these end up being 0.6 repeating? Okay, they all simplify to be the exact same thing. Now, the other pattern I want to look at here, do you guys notice that they did a really good job of going in order? So basically, they went from small to largest.
I didn't even recognize that.
Do you guys notice the pattern here?
Is it 8/9?
0.8 repeating, yep.
I got something wrong.
Okay, so what I need you guys to do is if any of these are wrong, I need you to go back to your scratch paper and fix it and correct it, okay? So let's go ahead, let's take a couple minutes here to go back. Don't just write in the answer, fix your work. Your work is what I'm going to be looking at. Okay, so the last thing we're going to do here before we start on our homework is I want you to go ahead and take a page back to your exit ticket. Okay. All right, so the first thing I want you to do here on your exit ticket, you should have plenty of room to write your work on your exit ticket, is I want you to divide and find the decimal for number 1, and then we're going to check it. So I'm going to give you about 30 seconds to a minute, and we'll see how you do here. How'd we do on number 1? Okay. So here's what's going to happen today. When you go to do your homework, you're going to do this exact same thing. You are going to divide it, you're going to get your answer, and then you're going to check it. If it's wrong, you need to go back and fix your work. So what I'd like you guys to do now is go back and fix your work if needed. If not, I want you to go ahead and get your bar notation down for number 1. How do you know that 4 elevenths was going to be a repeating decimal before we even divided it?
But it's proper.
Nope, proper fractions can be terminating or repeating. Careful with even numbers because that might get us eventually, so not necessarily even numbers. What did you say? Very good. Okay, I'm going to repeat exactly what you said here. Number 1, can 4 elevenths be simplified?
Yes. No.
No, right? So we're good to work with this. Okay, what he said is that 11 cannot be branched down into 2s and 5s. Do you guys agree with that?
Yes.
So because it cannot be branched down to 2s and 5s, we know that that was going to be a repeating decimal. Okay, in your own words, I want you to go ahead and write that down for number 2. Okay, so now number 3, they're asking, okay, what causes this pattern in long division? So when we look here, do you guys notice here, what was our difference here? Okay, what was our difference here?
4.
Okay, what was our difference here?
4.
Okay, so this is on a cycle. It's on a pattern cycle. So it basically creates a common difference in a pattern. So the pattern and the subtraction ends up being the same. So again, in your own words, I want you to go ahead and answer number 3 here. The pattern of the subtraction is what creates that repeating decimal. Because when we have that pattern happen over and over and over, we end up with a pattern up above in our decimal, because it ends up dividing the exact same way every single time.